Hello everyone, welcome back to Bioscience Network YouTube channel. And today we are going to learn how to dock with MOE. And in our last video, we learned how we can prepare the protein for docking. So today we are going to start docking properly. So in our last video, we stopped at preparing the protein and getting our active sites. So we got some active sites and then we selected them. Now to dock, we'll continue from where we stopped. To dock, we are going to go to compute and then dock. Now here we have two options. I have already selected my active sites. Yes, I have selected my active site, and here they are going to ask me what will I use as my receptor. If I have, since my receptor is already on screen, I'm going to leave it as receptor and solvent atoms. That is what I have. But if I don't have it, I can find the file I want to use for docking. So I click here, it opens my working directory, and then it makes use of it. Now, the next question he asks is my active site that is going to use for docking. Now, here you can use the ligand atoms since we have a ligand here, and it's going to use the active site where that ligand is to dock. Most of the times when you have your a co-crystallized ligand here, you can just select it and use it for docking. And then once docking starts, you remove it. That is, once you've started docking, you can come here and then click cancel here and it deletes automatically. Yes, and then but I don't think I'm going to use it here, so I'm going to use my selected residues where I selected, since those places are preferred for binding already. So I want the flexibility to be in such places. Now I realize that I have not prepared my ligand. So I am going to I am going to use an MDB file that I already have, but let's open it. We can see, so in ligands, I think, yes, this is it here, ligands.mdb. I created an MDB file, I think in a previous video. Yes, but this is different MDB, and these are a lot of ligands, and I don't want to make use of everything. So I can also import one more. I can import one more into this, and that will be LZ9 itself. I have it as an SDF. I am going to remove this, and then okay, good. I've added LZ9, but now I don't want to dock everything, and I don't want to make use of all these. I don't want to make use of all this, so I'm going to save as a different file name. Oh, let's say 4y72.mdb. I don't want to lose that other file, so I'm creating a new database file, and I'm going to remove some of these ligands too. I'm going to remove a lot. 3, 4, this. I think I'll leave it aside. Okay, this, this, this. Just use 6 of them. No. Okay, yeah, let me just leave this, and then selection, delete, selected. So 16 of these. Yes, so I'll make use of just these 7 ligands. So I close this down, I go back to my docking. Yeah, so I've selected my residues. Now this pH4 here is if you have a pharmacophore query, you want to set the type of binding that should be done while you are docking. If you just want I think donor receptor type of bonds, you want aromatic type of bonds, you can set those constraints there in the docking, but I don't have them here, so I just want to dock general docking. Then also if you have density files, and then for ligands, I am going to use, I'm opening my system and then using this database file that I just created. And once you select it, it shows you, oh, there are 7 ligands here. But if you did not select any ligand, it's going to show you ligand atoms. That is, that ligand that you had on it, the co-crystallized ligand, is what you are going to use to dock on it. That is, if you want to do a redocking. So since I have my ligands already, now we come to the method that we are going to use to dock. So uh, the basic one here is triangle matcher, and I think it's one of the best to use. It just tries to match the ligand into the active side and then places them there. And then there will be a much more stronger refinement. So the scoring in this placement method is London delta G. Yes, there are other scoring functions here, but this London delta G is best for this. And then for rigid receptor, for refinement, we are going to use rigid receptor. We'll try as much as possible to do um, rigid receptor docking first, and then in our next video we are going to do induced fit docking. We are going to see both of them, how they work. So here, for time's sake, I'm going to make this 5. No, let me make it 7 and make this 3. Okay. Yeah, so in my, I'm going to call this rigid dock. Now this is going to save on our working directory. So I think I have all my details. This is for refinements, either you make it induced fit or rigid. So what I want to do is I will do rigid first, and then my best scores, I'm going to use them for induced fit docking. So I'm going to run this. Selected atoms will be okay. Yes, good. So while docking starts, I'm going to remove this. Now for me to see where docking is going on, you come to this SVL and then we see it here. So docking has started, initialization has started, and it starts scoring out of 1,000 poses. Okay, so first docking is done, and once docking is done for each one, you are going to see them here. You are going to see your scores. So I want them to be very fast, so that's why I did it that way. Now this is the negative, the energy, binding energy here. Yeah, you can just, yeah, the final docking score is also the same thing as your E score 2 here, the final docking score. Now sometimes you might feel like this RMSD refine feels like it is RMSD. No, this is not RMSD with the co-crystallized ligand. No, this, when it does placement first, yeah, and if a refinement is done, the RMS, the movement of that ligand with respect to its initial placement is what this RMSD refine means. So I have 2 dockings done out of 7, and then we'll check back once the docking is done completely. So we have 6 out of 7 done. Surprisingly, this one that does not really look like a co-crystallized ligand has a very high energy. are all very low energy. Let's see, I think the last one, LZ9, this is a co-crystallized ligand, and it has started. So we'll work together with this and see how it binds. Since it's basically, we are basically redocking it onto it. Alright, 6 means 1. Okay, we're scoring. And oh, so docking is finished for something that we uh for something that we started. I can't really remember when we did, but it's a few minutes ago. That is one of the reasons I like MOE. It's really fast. Even induced fit docking is not as slow as autodock. Yes, it's not as slow as autodock for. It's faster and we can visualize it as it happens. So here our docking is done and this is already saved as rigid dock. So there's something else I'll still have to do. I'll save again as I want to save it because I want to remove some of them rigid results. Okay, I save this as rigid results and the extras, that is, I just need the first scores. I don't need the rest. So extras, I'm removing them. 1, 2, 1, 2, 1, 2. Right click selection and delete selected. So 14 of them gone. So I have this. These are the first scores. And then I'm going to rank them by their energy sorts ascending. Yes, good. So my best score was this, followed by, I don't understand why LZ9 is, as the co-crystallized ligand, has the lowest energy out of all of them. So I will pick, I think I'm going to pick, yes, for induced fit docking, I'm going to pick out of this maybe 3 or 4 to dock. But this is what we already have as our result. And if you want to visualize, you can come to, there's no need, you can come here to ligand here and then ligand interactions. Good. Or rather than doing that, we can still stay at where we were, file, and then browse. Good, good. So when we browse, we can see our ligand within these pockets. We can also see the bonds. I do not want to remove these selected atoms, but we'll still make do with it. So we have this here. You can be moving them with this arrow keys to the end if you want to the beginning if you want to. So we see the types here. You can change and switch one to the other. You can see them. This is LZ9. This is our best one. And then to see the interactions, I've already opened the ligand interaction section, and we can view them, the type of bonds formed. Okay, oh, this is really nice. Yeah, this is really nice. And then we can yeah. So options, I come to contact styles, select distance, apply, so that I can see my distance. So this ligand is a huge ligand, so no wonder it binds well. It just occupies space everywhere. Select the next one, apply, and then oh, okay, this selected atom. Oh, this is not it. This is right. This is right. FYZ to browser. Okay, that's what we want here. Apply. Good. This is what we want here. So basically what I did was initially it was using ligand atoms, and the ligand atoms in this file, I think it referred to the first ligand there or the places I selected. So I had to change it down to the browser since it's what I'm browsing through, the results I am browsing through, and that this is it here, this FYZ2, and then the ligand on FYZ2 is what we are making use of. So apply, and then this is the first ligand. Go to the next one, then we click apply again, changes to the other one, go to the next one, apply. You see the bonds formed, the contacts made. So you can save them if you want, export them as images, SVG, TIFF, any any picture quality you want, you can set them as that. So in our next video, we are going to learn how to do induced fit docking. Thank you for watching.